Hello friends, I am Agrawal, Assistant Professor in Civil Department, Sandipani Event Campus, Alati. Today's topic is Conjugate beam method. Now the learning outcomes. After watching this video, student will be able to understand the concept of Conjugate beam method, and also student will be able to calculate the slope and deflection by Conjugate beam method. Now here is a relation between loading, shear and the moments. So here d2m by dx square. So integration of this d2m by dx square is the dv by dx, which is the shear force. Again, integration of this dv by dx is the minus w, which is the intensity of load. Then again we have a relation here d2y by dx square. So integration of this d2y by dx square is the d theta by dx. So that is the slope. So again integration of the d theta by dx is the m by ei. So by observing these two equations, we can see that here this m by ei is the loading on the imaginary beam. That resulting shear and moment in the beam are the slope and deflection of the real beam respectively. The imaginary beam is also called as the conjugate beam and the same length and has the same length as the original beam. So for the imaginary beam, we have to apply the load as a m by ei. So shear force in the imaginary beam, which is equal to the slope in the real beam, and the bending moment in the real that imaginary beam or conjugate beam, which is equal to the deflection in the real beam. So the theorems here, the first term says that the shear at any point on the conjugate beam is equal, that is in sign and value, to the slope at the corresponding point on the real beam. So it says that slope at any point in the real beam, which is equal to the shear force at that point in the conjugate beam. And the second theorem is the moment at any point in the conjugate beam is equal, that is in sign and value, to the deflection at corresponding point on the real beam. It says that deflection at any point in the real beam, which is equal to the bending moment at that point in the conjugate beam. Now some of the keynotes, that is to first set up the additional beam, that is called as a conjugate beam, and next is to determine the shear forces and bending moments in the conjugate beam. Now here is some relation between the real beam and the conjugate beam. So first one, we know here simply supported beam. So in the real beam, we know here, so bending moment at the support A is 0 and the shear force is not equal to the 0. So it means shear force is having some slope. So in the conjugate beam where theta is not equal to 0, but the deflection is the 0. In the same, second is the rotor support. So that is same is the rotor support is here, where shear force is not equal to 0. It means here the slope is not equal to the 0, and here m equal to the 0, but so y is equal to the 0. Then in the cantilever beam here, so we know that at the fixed end, the shear force and bending moment both are not equal to 0, but at the free end, the shear force and bending moment is 0. But free end, we know there is a shear deflection and the slope. For that, we have to replace this end is a fixed end in the conjugate beam, so that we can get here the shear force and bending moment in the conjugate beam. So shear force and bending moments that indicate the slope at that point, and the bending moment indicates the deflection at that point. And at free end, this theta is not equal to 0 and the deflection is not equal to the 0. Then here the overhang beam that we know at the support A, which is the hinge support, where shear force is not equal to 0 and bending moment is not equal to the 0. So that is replaced again same, that is the simply supported, where the deflection, we know here the deflection is the 0 because of this support, and we know here shear force is not equal to 0, it means there is some slope. So that is why slope is not equal to 0 in the conjugate beam. So again the same support, this roller support, so that is the same is here. So intermediate support here. So that is replaced by here by the pin. So where this pin indicates that we know bending moment is not equal to 0 in the overhang beam. Also shear force is not equal to 0. So when there is a slope, there is some slope. That is why here theta equal to theta not equal to the 0, and as well as here the y is not equal to the 0. Now at the free end that we know is shear force and the bend moment both are 0, but there is a slope and deflection. That is why we have to replace this free end by the fixed end, so that we got some value of the shear force and bending moment which is equal to the slope and deflection of the radial beam. Thank you.